All right, so this is the second part in our Python programming webinar. Hopefully, from the first one, you got a little bit familiar with Python programming. You learned how to install Python, how to open the shell, use the command prompt, open up a new file, and write your first program. It all boils down to practice. So if you want to program and use it in your classroom, you just need to practice doing it. And it doesn't have to be overly advanced programs. The students are very proud of themselves with the basic introductory programming, and then you allow them to scale. So if they find interest in programming, they will program more. And a lot of times the ones that are going to do this long term are going to move, much quicker in the class. So the other thing is most students right now in the classroom have zero programming experience, at least with native coding, typing in the commands. They do have some drag and drop experience. They have some Scratch experience, but most haven't written a program start to finish, checked for errors, and run the program. So that being said, starting and introducing easy programs, shorter programs is fine with them. They don't know the difference yet. So this is programming part 2. Again, a couple of resources. You definitely want to hop over to the Python.org website, look through their material. Definitely download Python from the downloads link. 3.64 is the current version of Python. It'll prompt you to the new version. Teach Your Kids to Code is a great resource for the source code, and you can download that source code directly without purchasing the book. And then the Python standard library is a great place to build on your programming. And students are comfortable going there. They have great examples. They provide code examples for all of the questions that you might have. So a great resource. We do have a couple of new standards that we're going to cover. We'll be in algorithms and programming, which is the main standard alignment for CSTA. We'll be looking at variables, control, and program development. We'll create programs that use variables to store and modify data. We'll create clearly named variables. We're going to use sequences, events, loops, and conditionals today. We're always debugging and looking for errors in our programming and in our algorithm. We're going to try to use correct terminology as much as possible. That's always an area of growth for students. So as they need vocabulary, they learn vocabulary, and then they learn to use it correctly. We're going to test and debug a program. If we have any errors, we'll look for those errors. And then we can always describe the choices that we've made using code comments, presentations, and demonstrations. So those are kind of the areas that we're going to cover as far as alignment. We have 4 programs that we're going to write today. This is actually one of my most favorite programming days. When students run the square spiral program, you will just be amazed at oohs and ahs and the excitement you're going to have in your classroom. Beyond Hello World, they like Hello World. It shows a connection between programming, an input, a process, and an output. But beyond that, this is their first, for my class, this is their first introduction into using graphics and seeing a graphical output for their code. And the wheels they just spin. The kids love it. They start asking lots of questions. And this is the area where practice becomes important. I feel like you need to know more than your students in order to allow the learning environment to be as broad as possible. And so the more you practice with these programs, ask your own questions and find programming examples for your own questions, you'll be best prepared to help your students. And it's simple things like changing color or adding more colors or changing the background color. None of it is is too difficult, you just need to know it beforehand. So these are the 4 programs that we'll write today. Square Spiral 1, 2, and 3 are just iterations of themselves. They just get, we're just adding things to each one. And then Color Square Spiral is a slightly different version. And then we'll may have time just to add one little part and piece to that last one. A couple of vocabulary words that we're here today. We're going to be importing a graphics library. I try to describe this to my students as when they go to the public library or they go to the school library and they want to check out a book, they don't check out the entire library. They just get the book that is specific to what they need or they want to read. This is true for programming. We don't need to have all of the available functions in our program or available to our program if it doesn't intend on using them. So you can import the libraries that you need. If you're creating a game that needs to randomly generate gold or randomly generate stats, right, you would import the random library. If you want to import the math library, you might be adding that gold, dividing that gold, or doing other more complex functions with those numbers. You might import a graphics library. There's a variety of libraries that have functions that you may want to bring into your program. We import those libraries in. It saves space in the long run by not importing them all. So you can also write your own functions, which we learn much later on. That's usually by the end of 7th grade. I teach my students how to write their own functions, and they can actually import their own functions into another program. Variables is the way that computers store or remember information, right? Python can store a variety of different types, including numbers and strings, and that's primarily what we use in the programs that we write. Loops create repeatable actions or instructions, and you can tell the loop how many times, how many iterations that you want to go through very easily in Python. And then we're going to use a list. Lists allow you to store multiple pieces of information within a variable. So, for example, you may want, instead of just using one crayon in your program to change the pen's color, we may want to use a crayon box full of colors. So the variable is going to be called colors, and it's going to be equal to a list of colors. And you can have as many colors as you want in that list. Very similar to how you might add to a to-do list or any kind of other list that you might be using, like a grocery list. So those are 4 words that they are 4 pieces of vocabulary that they would pick up on during the course of this programming set. This is a cool program, activity-based program that I like to do with my students. And before we get into, actually, let me come back to that. We'll get into writing a couple of the programs, and this activity will make more sense when we come back. So what I'm going to do, let me find my mouse. There you go. Downsize that real quick. Nice clean desktop here, right? See all the things that I do. All right, so I'm going to open up Python. Over here I have the 4 programs already written. And since we have multiple programs to go through today, I'm going to open them. I'm going to put these, and I apologize, even though I had 4 straight days off. I did a lot of things besides work on my computer, so I will get these 4 programs into the resource library probably before this video is available. So I'll get them into a folder, get them shared onto the middle school computer science site for y'all. So I'm going to open the first one called Square Spiral 1. We're going to look at a couple of things here. Let me, so you might be able to see this better. Let me find. I was going to edit and make it a little bit bigger for you. But all right, so in the first case here, we have, I'm going to come up here to the top and use a comment to add my name. You always want to encourage your students to use comments when they can. Code gets shared, and coding should get shared. It's sort of a living thing. So you want to communicate within the code what your code is doing, what you're doing in different sections. You want to communicate to other programmers and people that may open your program up. I actually kind of take it as a piece of respect if someone was to take your program and want to open it up and make changes or mod it or add to it. It's just a sign of, you know, having a good foundation for a program. So definitely add in as much information as you think the next person may want to use. And I always have them put the program name on there. That way they know what to save their file as before they run it, because they're always asking, you know, what is the save name? And I tell them it's the program name, and it's on their program there. So that's just a little, if you're teaching it in the classroom, that just helps a little bit. So the first thing we're doing here is we're importing the Turtle Graphics program. And the Turtle Graphics program has been around for a long time, and it's a simple graphics program, but it does a lot.
Okay. So
and remember, it has sequencing.
I can hear somebody in my ear.
Convert the input, output the input.
And take the input, do something with it, do some mathematical operations with it.
Hey, Deepa, do you mind muting your mic real quick?
Possibly use an iteration. Make sense?
But it's just what produces the output.
That's right. That was that which eventually results in a value.
Hey, Deepa.
Hey there.
Hey, do you mind muting your mic real quick?
Oh, darn. I'm so sorry.
That's okay. That's all right.
Oh, darn.
So we have, the first thing we're doing here is we're importing the Turtle Graphics program. We're using a variable called pen to be equal to the drawing pen. So it goes into the Turtle Graphics program, and then it gets out a pen. This pen here must be capitalized. It represents a class within this Turtle Graphics library. This pen over here is a variable that I have named, and therefore I can lowercase the p as long as I use that same naming system everywhere that I want to use this variable. One of the things that I do, and we can kind of come back to this at some point, is I have there's a game online called Code Combat, and Code Combat allows students to use code in a role-playing game, and it's one of the better programs, online programs that I've seen that introduces a good, fun gaming format on top of a programming format. And what it does a lot of times is it uses this same system here, where instead of turtle it has the hero dot attack, or hero dot move forward, hero dot turn left, and by playing the game my students get familiar with attaching those functions to the actor, so to speak. So in this case we are getting out the pen from the Turtle Graphics program, and they're going to see down here how we're using this variable. So we import the graphics library here. We use a variable to be equal to our drawing pen. It's a generic pen. It has a 1 pixel width, and it has a black pen color. You can modify those attributes later. Here we set up a loop for x in range 500. We want to do something 500 times. The program is going to start, computer is going to start on 0, which means it's going to go through 499. In this program, for example, the last line in our drawing is going to be 499 pixels long, not 500, because that first length is going to be 0 since the computer starts with 0. So in our loop, we want our pen to go forward, and then we want our pen to turn left. So our pen is going to go forward x, whatever the value of x is in this range, again starting at 0, so it's going to go forward the first time 0, then the pen's going to turn left 90 degrees, then it's going to go back into the loop and the pen will go forward 1, the pen will turn left 9 degrees. The pen will go forward 2, turn left 3, turn left 4, turn left, all the way until it gets to the very last number in the range, which is 499. So we'll run that program and see what it does. So it's a very simple program, but the kids absolutely love it. So it just draws out 500 lines, each one pixel longer than the one previous, and then it turns 90 degrees to form this. I don't know, I always see it as I'm falling on top of a pyramid. Lots of my students see it as falling inside of a pyramid, I guess. So, but they really enjoy this. They start asking lots of questions. This is, you know, they begin to see that there's a direct output to commands that they're giving. Let me just put that down there. So if you notice, it's just going through this loop each time until it gets to 499. The very first question they ask is, can we do 10,000? And the answer is yes, you can do 10,000. You're going to probably only see 2,000 of those because your screen can only draw so much. But I also tell them, though, that in order to draw that many number of lines, they're definitely going to want to speed up the movement of the pen. So they recognize that they want to draw larger. I actually usually start this program with 100, but when I drew it on the screen, it was really small. So they immediately want to draw more lines. And so I'm like, okay, well, all you have to do is increase your range, because your range is what is determining the size of the drawing right now, because the larger the range, the more iterations in the loop, the more going forward, the more turning left. So we can definitely change that. If we go back to our program, we can change that to 1,000 if we want. But if you notice, this is still drawing. It takes a while at that pen speed, the generic pen speed that comes with this pen. It takes a while. So what we do is we come back over here and we can just do a pen.speed. We want to modify the pen speed. This pen variable here is equal to our drawing pen. So we're taking our pen and we're modifying its speed. 0 is the fastest speed. It just means 0 animation. They always want to put very large numbers in there, and I always tell them that 0 is the fastest speed. So we'll go ahead and run it again. We've doubled our range, but we've also increased the speed of the pen. So we modified one of the pen's attributes. And so when it draws again, it draws much faster this time. And we may even get to see all 1,000. In this case, it's going to end at 999. Here we go. Let's see. And if you were to look really closely, you can see that the very first ones down here it started out facing to the right, so it didn't go anywhere. It ended up facing up, and that's 1 pixel, 2 pixel, 3, 4, 5. And then you can come actually and count this last one is 999 pixels long. So that is Square Spiral 1, and it only gets better from here. That's a great program, first program to write for your students. They will definitely love that. So we're going to open up, let's see, we'll open up Square Spiral 2. Right, you'll notice that it looks very similar. I'm going to put my comments on there like I always have them do. So put your comments back on there, change that to a 2. I generally have them do this just in one document, but I wanted to share each one separately for you as a different file in the folder. We generally just stay within this one and just keep saving it and keep making changes. It's a lot faster, and it just shows more of the dynamic nature of programming. I don't want this one just to be 1 and this one is 2. They're all the same thing. You're just adding and taking away code. So I'm going to put the pen.speed back in here. I'm going to change the speed of the pen, one of its attributes, right? Because this pen, this generic pen, has a speed set to it. We're modifying the pen's speed here, so pen speed. We're modifying the pen's direction going forward and modifying the direction the pen is facing by turning left. So we're going to come back up here and change this to 1000. And then the only thing that we've changed is we've taken a 90-degree turn and we've changed it to a 91-degree turn. They quickly recognize that numbers can be changed within a program, and they change the output. In this case, they ask very quickly, can we change how far we turn left or right? I encourage them to start with 91 and then allow them to put any number in there that makes sense. We're going to run it again here. It's going to go faster. In this case, you get a much different looking picture, and this usually is this blows their mind. They think I'm trying to pull some voodoo on them or something, but it creates a really neat shape that spirals in. So 1 degree of change actually changes the picture in a pretty drastic way. All right, so that's the big change from spiral 1 to spiral 2. And then I usually give them most times the rest of the class just to modify these numbers. Couple of things about it. This is obviously it's just degrees in a circle. So if they turn 180 degrees, it's just going to draw a straight line because you're facing forward and going forward, and you're turning around and facing backwards and going forward. And if you do that repeatedly, you just draw a line. If they turn around 360, it's just like facing the same direction. So really your range in here is between 0 and 360, but a lot of those values don't make any sense or won't do anything. So they quickly figure out which ones do things, which ones don't. We'll run it one more time at let's say 103. I didn't test it that way, but we'll see what it does. So a much different geometric shape. And if they've been doing different shapes, they will recognize some of these. So one of the things I do encourage them to do is to use a range that doesn't always force the drawing off the edge of the window, so they can actually see how the shape looks when it ends. One of the other things is you can change how far forward it goes. So you can just double the direction, or double the distance it goes forward and run it again. And they start to be able to predict that that's going to open the drawing up a little bit. So it just kind of spaces the lines as they go forward. At this point, they're perfectly happy with modifying how far forward and to what degree left that the drawing does. So I usually give them the rest of the class period to mess around with these. We have laptops, so they're walking around and showing each other what they look like. So really cool what these end up looking like. We then use we have Microsoft at home, or at school too, so we usually use the snipping tool, and I show them how to very quickly use the snipping tool to do a full screen snip. Whoops, that's not what I wanted to do. No, I don't want to say that. To do a window snip, and they can save these screens. They drag them onto their Google Drive, and they take them home and show their parents the things that they've done. They love doing that. All right, square spiral 3, if I remember correctly. I'm going through these really quickly, but they're all going to be available to you. I'm just showing you how they work. We're going to come back over here and grab our comments. Always a good thing. Square spiral 3 is, again, this is all progression. It's a natural progression. They get tired of the pen color. And so they want to change the pen's color. So I'm going to modify the pen's speed here again. Again, the pen within the class has a generic speed, a set speed. We're just taking that pen's speed and modifying it. Now we're taking the pen's pen color and changing it. The default is black. In this case, we're going to change it to red. Python recognizes the basic colors that you will find in a crayon box for the most case: red, yellow, blue, green, cyan, gray, tan, that kind of stuff. The more complex color names it does not recognize. But one thing you can do is you can go out to use a website like HTML color codes, and you can use those color codes, and I can actually, if we have time, I can show you that also. So we're just going to, in this case, we're going back to our drawing. We're going to go back up to 1,000. I kind of liked the 2 times X there. I like spreading out the drawing a little bit, and we're going to go back to our 91. So all we're doing now is just taking the pen's color and changing that attribute to red. So we'll run it again. And you can predict the outcome, right? It just changes. And they can do this for, they say middle schoolers' attention spans like 30 seconds. They can do this for usually 30 minutes. I mean, they'll just change colors and change colors for quite the long time. So real quick, while we're on this one, what we'll do is I'll just show you at the same time that you can modify the pen's color, you can also modify the turtle graphics window that opens. This window that is being drawn in is a turtle graphics window, and it's in this case called turtle. And we're going to change the turtle's background color. And I'm just going to change it from white to black. So in the same way that we're using we're using the system here, taking the pen and modifying the pen color, we're taking the turtle graphics window and we're modifying the BG color or the background color. And we'll run that one more time. And that gives you quite a different look. And they can do this for a long period of time. They'll go through and change colors and change the degrees of forward or degrees of turning, etc. So very, very quick. So real quick, while we're on the colors, a great website to use that I use frequently with them is HTML color codes. I may have showed this before, but when you go onto the website here, it gives you this color box here. You can adjust the slider up and down, and then you can, I love blues, so let's go down here. And this is the preview color, and this is the color code that you need. It does have a hashtag attached to it, but as a color code that is not a comment. So I'm going to copy that. I'm going to come back to my program. I'm just going to paste it in instead of the red. So you want the hashtag and the entire color code. So if I bring that website back up, this is the color code. It does give you RGB color codes and hues, such whatever that is right there. But this is the easiest one to use the hashtag and the color code there. And you just copy and paste it directly inside the quotation marks, including the hashtag. So I'm going to run it again. This one looks really cool. So now we have this blue line. What I like about the HTML color codes is it gives you access to every single color that can be used. If you just use the naming of the color, black, red, blue, green, then you're limited to the names that Python recognizes. It recognizes all of the HTML color codes, and they're very easy to copy and paste in. I usually link the HTML color code website to the Google Classroom. They open it up at their laptop, and they have access to it right there in front of them. So the last thing that we're going to do, the last program that we're going to write, again, all three of these just build on themselves. So you can actually have them just write This is the progression from left to right. You can always just stay on this first one for a day or more. I mean, you know, a class period. I generally get all the way to the end of this. These are the 3 that I use within one class period. And the questions that they generate on their own is enough. So there's a lot of things. Adding the pen speed, changing the direction forward of the how far the pen moves forward, changing the degrees left or right. You know, changing the background color, changing the pen color. Those are questions that they're going to ask if they can do those things, and just be ready to introduce that code. All right, the last one I'm going to see. Now, the last one we're going to do is a color square spiral. And all we've done here is we've added a list. So I'm going to come back in here. I'm going to add my name. I'm going to add the program name. This one's called Color Square. And then we're going to change the pen speed. They get comfortable doing this. I usually, when I come in for a programming the next day, I'll just say, hey, open up a new file, you know, set up your graphics library, use a variable pen, and change the pen speed, and they'll do as much as they can, and then I go over it again, so it gives them a chance to practice before I get there. In this case, instead of just modifying the pen color once, we want to have multiple colors that we can use. So instead of having one crayon, we now have a crayon box. In this case, we have 4 crayons in our crayon box. You can once again use HTML color codes if you want to go out and do that. For time, I'm not going to today, but you can go ahead and do that. I am going to modify the background color to black. So we have the turtle window, graphics window, modifying the background color to black. It reads left to right a lot like a sentence. In this case, I have a box or a variable called colors. It's equal to a list of colors, red, yellow, blue, green. Now, the cool thing about this program is we're going to change the pen's color each time we go through our loop. So every time we go to draw a new line, we're going to use a separate color in the crayon box. And if you think about our colors in this list, they are in the same way that this range begins counting at 0. This range is 0 to 499. Our list over here is the same way. So we have, let me put my hashtag here real quick. Red right now is in the 0 position in our list. Make that easy. Yellow is at 1 in our list. Blue's at 2. And green is at 3. So even though we have 4 colors in our list, if I tell the program to go get within my colors list, go get the color at position 1, it's going to get yellow, not red, because red is at position 0. So what we have to do is, as the program goes through our loop, we need to tell it which color we want it to pick. It's easiest just to pick them in order. So what we do is we're taking the pen, modifying the pen's color by going to our list of colors, and this is how I want you to choose that color. I want you to use the variable x, right, which is the same variable that we're using to go through our range starting at 0 all the way to 499. And then I want you to divide that number by 4 because I have 4 colors. And then all I want you to do, this percentage symbol right here means I just want you to take the remainder of that division. So as we go through the loop, starting at 0, 0 divided by 4, whatever the remainder of 0 divided by 4 is, I want you to put that number here, and then take the pen's color, go to my list of colors, and use the number that is here, right? So to go back to our shell, I'll show you how that see if I still have a shell open. I may close it, so let me open a new shell. There's a way to, there you go. So to show you how that works, this is called mod. The percent symbol in division is called mod. So the very first number in our loop is 0. I'm going to mod it by 4. So if you go over here, the first number in our loop is 0 mod 4. If I hit enter, right, that gives me back a remainder of 0, which means my first color in this loop is going to be red, right? Then I go to 1 mod 4. The next color is going to be yellow. 2 mod 4. Next color is going to be blue. 3 mod 4. It's going to be green. And if you catch the pattern, 4 mod 4 is back to 0. And then the very last color, since we're going to 499, is going to be green. So using this mod, we're able to tell the program, take the pen, change the pen color, go to the list of colors, wherever we're at in the loop, take that number and divide it by 4 and use the remainder in here. And it will always be 0, 1, 2, or 3. We're going to go forward. So that's kind of a neat way. It's a very simple way to move through a list. So we're going to, we don't want to do that. We want to put those in 2. We're going to still turn left by 91. So we have 4 colors in our list. We have a background color that's black, and we're using this little tool here, a little trick, to move through our list. All right, so there you go. So we have, let's see, first color was red, so 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3 as it goes around. And I give them, usually the rest of class period to change the degrees left, change the distance forward, and to insert as many colors as they want. Okay, so keeping that in mind, those are 4 really good programs, and teaching about mod is very easy, right? Just go back and review it first, but it's very easy using the shell because it gives you immediate feedback, 0, 1, 2, 3, 0. And you can even keep doing it for 10 or 15 more just to kind of show there's a pattern there. All 4 of these programs progress or build on themselves. If I can get them all stacked up here. Boom. They all build from left to right. So this is the initial program, very simple. Modifying the pen speed, direction forward and left, adding a background color and pen color, and then actually taking that pen color and making it a box of crayon colors. A good activity that you can do with your class, if you take this program right here, I'm going to run it one more time. So a way to help them visualize how loops work, right, is I like to take them into the commons area, and we have these little, our commons area has 1 foot by 1 foot square tiles on the floor that that kind of represent pixels on a computer screen. So I like to teach them about loops by going out there. Let me find a program here. So what I do is I take them out there and I use like a large ball of yarn or like knitting string, and I put the one student in the centermost 1 by 1 tile on the commons area, and then we go through this program loop right here. So I have the student, another student takes the string and goes forward 0, right, and turns left 9 degrees. So you use the same student for the first one. Then you have the next student go forward 1 square, right, pulling the string with them, and then they turn left 9 degrees. And the next student takes the string, since it's again, it's like a long ball of yarn, they pull some string and they go 2 of the tiles, then turn left. And the next student goes 3 tiles, 4 tiles, and you eventually have, 25 students looping around with this ball of yarn, and it will model what this looks like right here on a very small scale. And then you can actually do, turning left 45 degrees, or turning, it's easiest with 45 over, say 91, but you can still do the turn left. It's very easy for them to see how a loop goes through its iterations one step at a time by physically using the students to draw out a loop using string. So it works really well with a graphics program. So I'll have my students do that. It's a cool little activity-based program. You can have the kids take a photo with a classroom camera or a phone or your phone, and then you can kind of show what they look like as the loop compared to what the program actually draws out as the loop. So it helps reinforce what loops actually do as they pass through each step. So what we learned how to do today was draw simple graphics with the Turtle library. We learned how to use variables to store simple number values and strings. And we learned how to change, save, and run programs in idle. So some pretty cool stuff there. If you would like to take on the challenge, you can write a Mad Lib program using a paragraph from a famous piece of literature and share the program with me. We looked at a little bit, the pattern for this we looked at last week. And I will address this more in our next one. So if you want to try to do this, you have learned enough from Python Programming 1 to use variables within sentences. If you can go out and find a famous poem, take one stanza from it, and pull out the verbs, the nouns, adjectives, and write a Mad Lib line for line. Keep it simple. Share your program with me, and I will comment on it. So you can always email those to me, or you can just include them in the discussion board for the middle school computer science site through EdWeb. Well, that's it for today. I appreciate your time, and I look forward to Python Programming 3. Thanks.